the polar regions are very important for our climate. The ice cover reflects sunlight, so it limits the amount of heat that is absorbed by the ocean. It's a big control on our climate on Earth, which affects everybody around the planet.
This whole environment is formed around sea ice. Almost every single animal that lives here is here because of the ice.
The Arctic sea ice has been melting over the last 40 years. Essentially, ever since we've been able to measure it, we've noticed a decrease. We don't really know the repercussions of such a drastically changing environment. When the temperatures and the ice changes, we don't really know how that is impacting the local ecosystem. And that's what we're trying to understand.
We are here in collaboration with Greenpeace to work on and understand changes in the Arctic. And a big change that's been happening is this shrinking of the ice and thinning of the ice in the Arctic. My name is Matthias Kape. I'm a biological oceanographer, study the ocean, and I'm coming from the United States, Seattle, the University of Washington.
Because it's so challenging and in some ways also dangerous to be out here, research in the Arctic is only a fairly recent enterprise for humans. We've only been doing actively science here maybe for the last 100 years or so. My name is Till Wagner. I'm an assistant professor in physical oceanography at the University of North Carolina, Wilmington. And my research is concerned with sea ice, the polar oceans, and their role in the climate system. And one thing that always happens is that one type of scientist comes out here. So we have a physicist trying to understand the sea ice, or we have a marine biologist trying to understand the behavior of the whale. But everything is very interconnected, and that's what we're trying to fill the gap in here, is trying to have scientists of all disciplines working together and trying to piece this puzzle together.
The spring is an important time in the Arctic because it is when we're seeing the start of the sea ice melting, polar water coming down and Atlantic water coming up. So this combination of mixing of these two water bodies with increased temperature causes the ice to melt, and that releases nutrients into the water from the algae that live underneath the ice.
My name is Hillary Glandon. I am a postdoctoral scientist at the University of North Carolina in Wilmington. I am helping to identify marine mammals and birds, also to look at zooplankton and measure the water for carbonate chemistry.
When you have the right conditions where you have nutrients available and light, the phytoplankton will grow, and often there will be a phytoplankton bloom. And so when that happens, we have lots and lots and lots of food to eat for all the upper levels of the food chain in the water. So it's really this physical mixing and the increased temperature that kind of triggers all of that.
So right now we're here on a pretty small ice floe, a little bit in from the ice edge. We're at about almost 80 north and 4 degrees east, roughly, which means we're about 100 miles off the coast of Svalbard.
So this ice, if we look at the surface, there's ridges and topography, but it is very white. If we look underneath, what we would see is green. It is a microscopic forest growing within and on the bottom of the ice. And this ice in certain parts of the Arctic is one of the main food sources for everything growing in the ocean. In the central Arctic, near the North Pole, over half of the food for the rest of the ecosystem is provided by ice just like this one.
This is a perfect example where we have this sort of patchy ice flows, so they've been starting to melt, and we've measured the thickness of the ice in 2 perpendicular directions at every 5 meters. And then also the depth of the snow, because there's a little bit of snow here now. And then we've also taken 2 ice cores.
And what we're trying to understand is A, where did this ice floe come from, and B, how old is it, and C, what are the creatures and nutrients that reside inside the ice floe.
Generally near ice there tend to be many more zooplankton. So we've been looking here at the ice and we found quite a few here just near the ice, some meters from where I'm standing. And we're comparing that not only from this ice sampling compared to what we see on the ship and what we find farther south, to try to understand where these building blocks of the marine ecosystem are located.
The main goal is to characterize, the whole Arctic ecosystem from the ice all the way to the marine mammals. And so one of those middle levels is the zooplankton. So we're taking a subsample of the zooplankton and looking at them under this microscope. And this just allows us to sort of qualitatively, while we're on the ship, understand how the community of zooplankton might be changing as we move around.
And what we're doing on the ship also is collecting some of this water, ocean water, at the surface but also at depth. And what we use to do that is called a rosette. And we take it from the ship and lower it into the ocean to 300 meters, to where it's very, very dark and even colder than we have here at the surface. On the rosette, there are a number of bottles, and the bottles allow us to collect water. From this water, we can look at what phytoplankton there are, potentially the amount of nutrients there are. Nutrients are important for phytoplankton to grow, like fertilizer in our gardens. So we use this, and we have instrument on the rosette, which we use to look at the temperature of the ocean, and hopefully add that to data collected by collaborators to see how the temperature of the ocean has changed. Once we have that data in connection with the sea ice, we can see for this time of year how the warm temperature is affecting the ice cover, and then compare that to previous years. Scientists have now projected that by the 2100, which isn't too far away now, there might not be any summer sea ice in the Arctic at all, which means that now the Arctic Ocean will be an ocean without any ice.
Almost every single animal that lives here is here because of the ice, right? So if you start at the bottom of the food chain, algae live under the ice, right? So if there's no ice, then there will be less algae because there's less space. And if there's less food, then you'll have less upper predators, or maybe some of those predators would shift what they're eating. So not only do these upper predators rely on the food that's found in the water, but many of them rely on the ice for breeding, for mating, for living. Like if you think of a polar bear, they live on the ice. And so really every level of the food chain would be affected in some way, if not directly, indirectly, by the loss of ice. Us gaining a deeper understanding of the processes here will help us to make more informed decisions about what may happen in the Arctic in the future.